Hello everyone, this is Sir Marvin Bertido. So for our 20th lesson, we're going to discuss flow nets. Alright, so for this discussion, we're going to tackle the Laplace equation of continuity, flow nets, seepage calculation from a flow net. So we're going to discuss here yung flow nets in isotropic soil and flow nets in anisotropic soil. And we're going to solve sample problems. Alright. Alright, we are now going to proceed to the second part of the fifth chapter. So we are going to talk about seepage. Alright, so class, in the first part of our discussion in chapter 5, so that is about permeability, we considered some simple cases for which direct application of Darcy's law was required to calculate the flow of water through soil. So class, yung application ng Darcy's law is just for one-directional flow of water only. Pero in many instances, class, okay, yung flow ng water through soil, hindi lang talaga siya one direction. Okay, so hindi rin siya uniform over the entire area perpendicular to the flow. So, sa mga ganong cases, class, no, na hindi na lang siya one-dimensional, no, let's say two dimensions, so yung groundwater flow, class, is generally calculated by the use of graphs referred to as flow nets. Okay, so itong flow nets, class, pwede natin itong gamitin to calculate the flow of water through soil in two dimensions. Okay, so class, yung para doon sa 3 dimensions, hindi na natin siya pag-uusapan dito kasi class, medyo complicated na siya. So in this case, class, we will focus sa flow nets, no? So class, yung concept ng flow net, this is based on Laplace equation of continuity which governs the steady flow condition for a given point in the soil mass. So para dito, class, sa chapter na to, no, pag-uusapan natin yung derivation ng Laplace equation of continuity. We're also going to discuss the procedure to construct flow nets, calculation of seepage in isotropic and anisotropic soils, and we're going to talk about seepage through earth dam. So let's start our discussion. Right. Let's now derive the Laplace equation of continuity. Alright, so class, to derive the Laplace differential equation of continuity, the first thing that we're going to do, we are going to consider a single row of sheet piles that have been driven into a permeable layer as shown in figure 8.1a. So ito, class, yung figure 8.1a. So meron tayo, class, ditong single row of sheet piles, which is ito yon. Okay, so naka-side view yan, class. Okay, so ito, class, ay sheet pile. So para siyang wall. Okay, so ito, class, ay driven dito sa permeable soil layer na to. So ito, class, ay permeable soil layer. Ito. So nakatusok siya dyan, class. Okay, so dito, class, itong permeable, itong sheet pile na to, class, ay impermeable siya. So ibig sabihin, hindi pwedeng tumagos yung water dyan. And as you can see here, class, meron tayong water dito sa side na to, no? And meron din tayong water dito sa side na to. So ito, class, sheet pile natin, no? It serves as kumbaga harang, no, dito sa dalawang water, no, sa dalawang side. All right. So dito, class, no, the steady state flow of water from the upstream to the downstream side through the permeable layer is a two-dimensional flow. Okay. So, class, di ba alam natin na ang water, nagfo-flow lang yan, class, no, from high energy to low energy, or from high head, okay, to low head. So, kailangan magkaroon, class, ng difference ng head for a fluid or water to flow. Tama ba? So, in this case, class, no, as we can see here, yung side na merong mas mataas na head or energy is itong side na to, class. Tama? So, ito, class, ay tinatawag na upstream. Okay? And dito naman, class, sa kabila, alright, so ito, class, ay may mas mababang energy or head. No? So, ito, class, ay tinatawag na downstream. Okay? So, class, sa madaling sabi, no, yung fluid or water natin, class, no, through the impermeable soil, magfo-flow yan, class, from upstream to downstream. Alright? From upstream to downstream. Okay, pero in this case, class, since merong nakaharang, itong sheet pile na to, so of course, hindi yan pwedeng mag-flow from here to here. Kasi nga, hindi naman siya tatagos dun sa sheet pile natin, no? So, kailangan niya muna, class, umikot dito sa sheet pile na ito, no? So, yung magiging flow natin ay from upstream, dadaan siya papunta dito, class, hanggang makapag-flow siya papunta dito sa downstream. Okay, and take note, class, na yung magiging flow nung water natin from upstream to downstream ay two-dimensional, ha, in this case. Okay, so, class, dito, kung two-dimension, of course, merong dalawang axes yan. No? So, in this case, class, yung two-dimensional flow natin, no, or yung dalawang axis natin dito, class, is yung x-axis at saka yung z-axis. So, yung x-axis, class, yan yung horizontal axis or horizontal direction. And then, yung z-axis naman, class, yun yung gagawin natin ditong vertical, no, na direction. Alright, so, after nun, class, no, we're going to consider a point, no, so, a-analyze natin, no, yung flow, let's say, at point A. So, let's say, class, na nandito yung point A. Alright, so, class, let's consider a point here. Yun nga, kuha tayo ng point mula dito, no, and sobrang liit nung point na yan, class, at kung i-blow up natin yan, class, alright, ito, class, yung magiging itsura niya, no. So, this is an elemental soil block, no. So, i-consider natin yung point na elemental soil block. So, cube siya, no, na pare-parehas yung dimension yan, class. Alright. So, class, let's say na itong block na ito, meron siyang dimensions na, let's say dito sa horizontal axis, no, dx, and then sa vertical, dz, and then dito, class, sa may forward, backward. Alright, so yan ay dy. So, class, yung dy yan ay, ano ha, yan yung axis na perpendicular sa screen or sa paper, dito, perpendicular. Alright. So, in this case, class, yung flow nung water natin ay, ano ha, nasa x direction at saka z direction. Alright. Alright, so, we are going to let v sub x and v sub c be the components of the discharge velocity in the horizontal and vertical directions, respectively. Alright. So, class, we're going to assume na, let's say, as the water, no, enters, no, dito sa soil element natin na ito, class, no, let's say in the x direction. So, as it enters, no, this soil element, class, let's say na yung velocity niya, class, ay v sub x. Okay? And sa z direction naman, let's say yung velocity niya, class, as it enters, no, the soil element in the z direction, let's say v sub z. Alright. So, class, the rate of flow of water into the elemental block in the horizontal direction is equal to v sub x dz dy, and in vertical direction, it is v sub z dx dy. Alright. So, class, di ba yung rate of flow natin, yung formula natin doon, IQ is equal to VA. Tama? Wherein yung V ay discharge velocity, and then yung A is yung cross-sectional area na perpendicular dun sa flow. No, so in this case, class, let's say for the x direction, okay, so yung magiging rate of flow ng water natin, class, papasok dun sa soil element natin ay V times yung cross-sectional area. So yung cross-sectional area, class, na perpendicular, okay, dun sa flow natin ay ito, sa x direction, ha, itong dz times dy. Tama? So sa madaling sabi, class, yung rate of flow natin, no, as it enters the soil in the x direction ay v sub x times dz times dy. Ngayon naman, class, sa z direction, so ito yung vertical, so yung rate of flow nito, class, ay v sub z times yung cross-sectional area na perpendicular dun sa flow, which is itong dx times dy. Tama? So, kaya, class, yung magiging rate of flow natin ay v sub z times dx times dy. Alright. So, the rates of outflow from the block in the horizontal and vertical directions are ito. So, class, itong ano natin, itong rate of flow or velocity, no? Class, yung velocity natin, alright, so as it enters the soil element in the x direction, so v sub x, di ba, initially. Ngayon, class, kapag lumabas na yan, class, dun sa soil element, alright, so, class, yung velocity natin, class, yan ay magbabago. Okay, so it will change, class. So, magkakaroon tayo dito, class, ng dagdag na term, no, ito class ay para dun sa change nung velocity, no, as it enters, no, or as it exits, no, the soil element. So ito class, no, yung magiging velocity niya kapag umexit siya dun sa soil element natin is yung initial plus yung change dun sa velocity. So itong term na to class ay para sa change dun sa velocity, or this is rate of change, no, in velocity. Okay, so kung flow yan class, okay, kung flow naman yan class, i-multiply lang natin yan class dun sa area na perpendicular dun sa flow, which is dz times dy pa din. No? So ito class yung magiging outflow. No? Ito yung magiging rate of outflow. So ganun din class dito sa z direction. Alright, so ito initially yung velocity niya as it enters the soil element, and as it exits the soil element, no, magbabago class yung velocity. So magkakaroon class dito ng term na para dun sa change, no, in velocity, no. So ito class ay rate of change in velocity, itong term na ito. So yan class ay v sub z plus ito, and then i-multiply lang natin yan class sa cross-sectional area na perpendicular dun sa flow, which is dx and dy. Alright, so ito class yung mga rates of outflow. Okay, so ito yung inflow, ito yung outflow. Dito rin sa z direction, ito yung inflow, ito yung outflow. Ngayon class, yung idea natin dito is that we're going to assume na yung total rate of inflow dapat equal siya dun sa total rate of outflow. Okay, so obviously, dapat kung ano yung pumasok na rate nung flow, no, dapat siya din yung lumabas na rate ng flow. Okay, so in this case, class, ito class ay outflow, di ba? Itong outflow na to class, yung rate of this outflow plus rate of this outflow, ito yon. Tsaka ito. So, kapag class sinubtract natin yan dun sa inflow natin, which is ito, tsaka ito, okay, dapat class yan ay equal sa 0. Okay, so class, kapag ito ay sinimplify natin, alright, so may mga makakancel tayo dito. Ayan, tingnan natin kung ano yung mga pwedeng makancel. Alright, so pwedeng makancel class dito yung vx, dz, dy, which is ito. V sub x, no, times dz, dy. So makakancel yan. Tsaka ito. And then dito, v sub z times dx, dy. No? Ayan, makakancel din siya. Ito, no, kasi negative siya dito eh. And then yung matitira sa atin dito class is ito, yung partial v sub x over partial x times dx times dz times dy plus partial v sub z over partial z times dz times dx dy. Okay, so dito class, ang mangyayari, ito yung matitira, tama? Tapos dx times dz times dy. Tapos times dz times dx times dy. So yung mangyayari class, pwede natin i-divide both sides, no, by dx, dz, dy. Tama? Para makakancel siya class. No, and yung matitira class ay ito, yung partial v sub x over partial x plus partial v sub z over partial z is equal to 0. Okay, so we will take this down as equation 8.1 class, ha? Alright. Alright. So, class, with Darcy's law, the discharge velocities can be expressed as, ayan. So, di ba class, using Darcy's law, yung formula natin, class, is V is equal to K times I. Okay, so dito, class, no, yung v sub x natin, which is ito yung discharge velocity in the x direction. So, using Darcy's law class, no, yan ay ki, so k sub x, so yan yung hydraulic conductivity in the x direction, and then yung I sub x, ito yung hydraulic gradient in the x direction. Or ito class, yung I sub x natin, pwede natin to isulat class as partial h over partial x. Alright, so ito class yung magsaserve as head loss, yung partial h, and then itong partial x, ito class yung length, no? And then class yung v sub z naman, alright, or ito class yung discharge velocity in the z direction. So equal yan class sa k sub z times I sub z, wherein again, yung k sub z, yan class ay hydraulic conductivity in the z direction. And then yung I sub z natin, pwede natin siya class isulat as partial h over partial z, wherein itong partial h nga, yan yung magiging head loss, and then itong partial z, ito class yung magiging length, no? Alright. Alright. So, class, ito yung mga equations na nakuha natin, equation 8.1, and then yung dalawang equations na to, class, from Darcy's law, ito. So, class, dito, class, pwede nating i-substitute dito sa v sub x, no, yung nakuha natin na to, na v sub x, ito. Alright, and also for v sub z, pwede nating i-substitute yung nakuha nating v sub z na ito. Alright, so substitute natin, class. So, what happens is that yung v sub x, papalitan natin ng k sub x, tapos partial h over partial x. So, yung mangyayari, class, yung k sub x ay ito. And then, ito, class, ay partial h times partial. No? So, yung mangyayari dyan, class, ay magiging partial squared h over, ito naman, partial x, tapos ito partial x din. So, it will become partial x squared. Tama. So, dito naman, class, sa may v sub z, so ganun din, papalit lang natin to. So, it will become k sub z times partial squared h over partial z squared. So, this will be equal to 0 pa din. Alright. So, dito, class, kung yung soil ay isotropic with respect to the hydraulic conductivity, so, ibig sabihin, class, yung hydraulic conductivity in the x direction equal siya sa hydraulic conductivity in the z direction. So, ito, class, no, pwede natin ito, class, i-divide both sides. Since yung k sub x at k sub z, let's say, ay equal, no, so pwede nating i-factor out, tama, yung k na yon. And then, pwede nating i-divide both sides by k. So, yung mangyayari, class, makakancel yung hydraulic conductivity. And yung equation natin, class, it will become this equation. Okay, so class, ito yung Laplace equation of continuity. Okay? So, class, itong Laplace equation na ito, class, it represents energy loss through any resistive medium. So, in this case, class, yung nire-represent dito, class, no, sa sinolve natin na to, class, ay head loss. No? So, yung energy natin dito, class, ay head loss. So, again, it represents head loss through any resistive medium, which is yung soil nga natin, no? Alright. So, dito, class, no, if you are going to solve this equation, no, yung lalabas dito, class, is a function of h, no, in terms of x at saka z, wherein yung x at saka z, yan, class, ay mga coordinates, no, or kumbaga location, coordinates ng location ng anumang point dito sa system na ito, no. So, class, kapag nakuha natin yun, no, and alam mo yung x at saka z or any point niya, so pwede mo, class, malaman yung head at that point. Okay? Okay. So, class, yung solutions para dito sa Laplace equation, it can be analytical. So, yan, pwede mong gamitan yan ng mathematics, pwede mong gamitan ng differential equation. And yung ikalawa, class, is yung graphical. So, in this case, class, magfo-focus tayo doon sa graphical solution, ha, dito sa Laplace equation. So, yung ginagamit natin, class, na graphical solution is yung tinatawag natin, class, na flow net, which is doon tayo, class, magfo-focus, no, dito sa discussion natin. We're going to discuss, no, yung flow net. Alright. Alright, let's talk about flow nets. Okay. So, class, yung continuity equation na na-derive natin in an isotropic medium represents two orthogonal families of curves. No, so, yun, class, ay flow line at saka equipotential lines. Okay, so, class, itong flow lines at equipotential lines, i-define natin ito dito. Okay, so, class, yung flow line, it is a line along which a water particle will travel from upstream to the downstream side in the permeable soil medium, no? So, class, as you can see here, okay, so alam natin, class, na yung water natin, no, magfo-flow siya, class, from upstream to low stream. And ngayon, class, no, alam natin na yung water, composed yan ng mga water particles, tama? No, so, let's say, class, meron tayong water particle dito sa point na ito. Alright. So, class, yung line, okay, or yung path kung saan, class, dadaan yung, or magfo-flow, yung water natin, class, from upstream to downstream, yan, class, ay tinatawag na flow line. Alright, so let's say, dito ka, class, may water particle, no? So, yung water particle na yun, class, from upstream to low stream, magke-create yun, class, ng flow line like this. Okay, so pwede rin dito, na may water particle dito. Alright, so yung magiging flow line niya will be drawn something like this. Alright, so plus yung flow line, no, minsan tinatawag din siya na streamline. Okay, so yan, ulitin ko, yan yung path class kung saan yung water particle ay nagta-travel from upstream to downstream. Alright, side. Upstream to downstream side. Alright, ngayon class, yung equipotential line naman, it is a line along which the potential head at all points is equal. So kung maglalagay tayo class ng piezometer, no, at different points along an equipotential line, so yung water level will rise to the same elevation in all of them. So ito class, no, as you can see here, ito class ay equipotential line. No, so ito class, no, mapapatunayan natin na equipotential line yan, no, kapag naglagay tayo class ng piezometer, no, at any point along this line, class, yung mangyayari, yung rise ng water level dun sa piezometer will be the same, no, at any point, no. So ibig sabihin class, equal yung head, no, at all points, no, kapag nasa iisang kumbaga equipotential line. So class, yan yung definition natin ha ng equipotential line. Alright. Alright, so now yung combination class nung number nung flow lines at saka equipotential lines, yan class ay tinatawag na flow net. Alright, so ito class, no, ito ay example ng flow net. Ito. Okay, so ito class ay composed ng ilang mga flow lines at saka equipotential lines. Okay? So, class, as mentioned in the introduction, flow nets are constructed for the calculation of groundwater flow and the evaluation of heads in the media. And so, class, yan yung mga pwede natin na makuha, no, sa pagka-construct ng flow nets. Okay, so pwede natin class makalculate yung groundwater flow and mga heads, no? Pwede nating makalculate yung heads, no, at any point doon sa ano natin, doon sa let's say dito sa flow net natin. All right. So dito class, no, paano ba natin kino-construct, no, yung flow net, no? So to complete the graphic construction of a flow net, one must draw the flow and equipotential lines in such a way that, una class, the equipotential lines intersect the flow lines at right angles. Okay, so dapat class ha, right angles. Ayan, yung, kumbaga, mafo-form, no, kapag in-intersect natin yung equipotential line dun sa flow line. Alright, so also, the flow elements formed are approximate squares. Ayan. So, plus yung elements dito or yung flow elements na tinutukoy is ito, yung mga approximately squares na na-form. Ayan. So, class, ang tawag natin dito ay mga flow elements, ha? Alright. So, dito class, no, kasi pwede mo class maisip, no, na, sir, paano namin malalaman kung gaano kadaming flow nets or flow lines, gaano kadaming equipotential lines? Actually class, no, yung number of flow lines at equipotential lines na pwede nating i-drawing ay infinite. 'Di ba? Kasi kung isipin mo class, no, at any point na yan, no, infinite, kumbaga halimbawa dito, no, so ang daming water, ano dyan ang daming water particle dyan, tama? And therefore, kung may water particle dyan sa mga points na yan, so magkakaroon class yan ng flow line from upstream to downstream. So, infinite class yung number of flow lines na pwede natin class na i-drawing. Kaya lang class, ang problema, yung rule natin class sa pagka-construct ng flow net, dapat class, no, merong ma-form na approximate square. So, ibig sabihin, kung infinite yung ilalagay mo dito class na flow line, dapat infinite din yung idodrawing mo na, kumbaga, equipotential line. Kasi, dapat ang ma-form is, approximately square, no? So, ganun class yung rule dito, no? So, ibig sabihin class, no, kumbaga, dito class yung flow lines, no, pwedeng yung i-drawing mo is mga 3 to 6, no, na flow line. So, enough na yon. And then, yung equipotential lines class. So, itatansya mo yun class na kumbaga class, yung mafo-form na mga flow elements ay mga square, approximately square. So, kapag sinabi natin class na approximately square, no, it doesn't mean na yun nga, na kailangan perfect square siya. So, yung, kumbaga, definition natin dito class na yung approximately square, no? So, dapat class is dun sa mga flow elements natin, meron tayong maidodrawing na circle na matatouch niya lahat ng sides. No? So, halimbawa, dito, no? So, pwede ba tayong mag-drawing dyan ng circle? So, kapag pwede na makapag-drawing ng circle, so, ibig sabihin nun class na approximately square na yon, no? Ayun. Okay. So, that's the rule class dito sa pagdodrawing natin class ng flownet. Okay. Alright. Figure 8.2b. Ito yon. Alright. Shows an example of a completed flownet. One more example of flownet in isotropic permeable layer is given in figure 8.3. So, ito class yung figure 8.3. So, ito class ay flownet din. Alright. So, class in these figures, no, so yung N sub F, no, yan yung number of flow channels in the flownet, and yung N sub D, yan yung number of potential drops. Okay, so, yung flow channel class at saka yung potential drop, later on class yan ay iano natin, no, i-detalye natin. Okay, pero dito class yung number of flow channel. So, class yung flow channel na tinutukoy, yan class yung path na nasa pagitan ng dalawang flow line. Okay, so in this case, halimbawa, itong dalawang flow line na to. So, yung path na nasa pagitan niya na ito. So, ito class ay tinatawag na flow channel. Ito din, di ba, ito ay flow line. Ito rin, flow line. Okay, so ito class ay tinatawag din na flow channel. No, yung path sa pagitan ng dalawang adjacent na flow lines. And then, yung potential drops naman class, no? So, kung dito sa figure na to, no, yung potential drops niya ay ito, mula dito hanggang dito, isa. Mula dito hanggang dito, dalawa. Mula dito hanggang dito, mula dito hanggang dito, mula dito hanggang dito. So, kung bibilangin natin, isa, dalawa, tatlo, apat, lima, anim. So, anim class yung potential drops dito class sa flow net na ito na. Pero idedetalye natin class yung definition niya ng potential drop at saka ng flow channel. Alright. So, drawing a flow net takes several trials. No? So, while constructing the flow net, keep the boundary conditions in mind. So, for the flow net shown in figure 8.2b, the following 4 boundary conditions apply. So, kailangan natin class tandaan, no, itong mga boundary conditions na ito. So, yung unang boundary condition, the upstream and downstream surfaces of the permeable layer, yun yung line AB at saka line DE, they are equipotential lines. Okay, so yung binabanggit class na upstream, yung AB, ito daw yan, ito to. Okay, so yung surfaces ng permeable layer ng lines AB, or nung upstream, ito yon. Okay, so ito kasi yung upstream, di ba? Yung upstream side. So, yung surface daw class ng permeable layer nila, which is ito, yung surface ng permeable layer, tapos tubig yan. So, ito yung surface ng permeable layer. So, ito class ay line AB. Ganon din sa downstream naman, ito yung downstream. Alright, so, yung surface ng permeable layer dito sa side na to ay itong DE. Tama? Alright. So, sabi dyan class, yung lines AB, ito, tsaka line DE. Okay, so class sila daw ay mga equipotential lines. Okay, so kung babalikan natin yung definition ng equipotential line, sabi, dyan sa line na yan, no, at any point, no, same class yung head. Okay, which is, ano naman, pretty much obvious naman, no, as we can see here, dito sa, let's say, sa line na ito, line AB, at any point naman, diba, same class yung magiging head, which is ito. Tama, and kung kasama din yung elevation, no, let's say yung datum ay nandito, so kasama din to sa head. Ito plus ito. No, so ito ay due to the pressure of water, no? Ayan. So dito class at any point same yung head nila. And ganun din dito sa line DE. No, at any point dito sa line DE class, same sila ng head. So sila class ay mga equipotential lines. Pero class magkaibang equipotential line ang AB at DE, ha? They are not the same. Alright, so kailangan mong tandaan yan class, yan yung unang boundary condition natin. Ito class, line AB at line DE. Yan class ay mga equipotential line. So yan yung mga surfaces no, nung permeable layer dun sa upstream at downstream. Alright, dun tayo sa second boundary condition. Because AB and DE are equipotential lines, all the flow lines intersect them at right angles. Okay, so kaya makikita mo dito class, alright, di ba rule natin yon sa pag-construct ng flow net na dapat class yung flow line magi-intersect siya sa equipotential line and vice versa ng 90 degrees. So in this case, since itong AB at DE ay equipotential line, so kailangan yung flow line okay, magi-intersect sa kanya ng 90 degrees, approximately 90 degrees. Ayan, so dapat 90 degrees yan. Alright. And then, yung third boundary condition natin, class, the boundary of the impervious layer, that is line FG. Nasaan ba yung line FG? So, ito, class, yung line FG. So, ito kasi, class, yung permeable layer natin. Tama? Ito yung permeable layer. Tapos, itong nasa baba, nung permeable layer ay impervious layer. So, pwedeng yan ay rock, no? Ayan. So, ito, class, ay impervious layer. So, sabi dito, class, na itong line FG, class, ito ay flow line. No, so from F, no, pwede class mag-flow yung water natin from F papunta dito sa G. Okay, so ito class ay flow line, ha? Alright. And so is the surface of the impervious sheet pile line ACD. Alright, so ito class surface ng impervious sheet pile natin. Ito yung sheet pile. Okay, so yung line A, ito yung line A. Tapos C, tapos D, pa ganon, mula dito sa A, papunta dito sa C, papunta dito sa D. Class yan din ay flow line. Okay, so ulitin natin ha, ito class ay flow line, ito ay flow line, no, yung line ACD. No, yan yung surface class nung ano natin, impermeable sheet pile. Okay, so tandaan mo yan class, yan yung third boundary condition natin. And yung fourth, the equipotential lines intersect ACD and FG at right angles. Okay, so dahil nga mga flow line din yan, yung FG at saka itong ACD, so yung mga flow lines natin or itong equipotential line natin, no, magi-intersect din sa kanila ng 90 degrees dapat. Alright, alright. Ito 90 degrees, 90 degrees, 90 degrees. Alright. Okay, so ito class yung mga 4 boundary conditions natin, ha? Okay, condition 1, condition 2, condition 3, condition 4. And so sa madaling sabi class dito, no, ulitin natin, no, i-summarize lang ulit natin. Alright, so ito class ay flow line. Flow line, flow line. Ito ay equipotential line. Ito class equipotential line din to, equipotential line, equipotential line. Alright, ito class, ano ito? Yung AB. Ito class ay equipotential line. Ito rin, equipotential line. Yung ACD class ay flow line. And then FG class ay flow line. Alright. Alright, so ngayon class, proceed na tayo dun sa seepage calculation from a flow net. Alright, so class, meron tayong dalawang case dito sa pag-compute ng seepage, no, from a flow net. So yung unang case natin class is for isotropic soil. Okay, and then yung ikalawang case is for an isotropic soil. So, class, yung isotropic, as we have discussed, no, ibig sabihin yan, class, is yung hydraulic conductivity, no, sa X at Z direction or sa horizontal at vertical direction ay the same. Dito naman sa anisotropic, magkaiba. Alright, so, class, we will start with the flow nets in isotropic soil. Alright, so class, in any flow net, the strip between any two adjacent flow lines is called a flow channel. Ayan, so nabanggit ko na yan kanina, class, yung flow channel. Alright, so class, if you have a flow line, so let's say itong flow line na to, tapos ito, adjacent flow line niya ay ito. Alright, so class, itong strip sa pagitan nila, yan ay flow channel, ha? Alright, so kinuha natin itong portion na to. Alright, so this is a flow channel, no? So naka-blow out, blow up din siya dito. Alright, so this is a flow channel class. Okay? So, itong flow channel na ito class, na-form na-form ito, ulitin ko, because of two adjacent flow lines, ha. Alright, and then as you can see dito sa flow channel na to, class, no, merong mga square elements dito. Tama? So, class, yung mga elements na yan, yung square elements na yan, alright, yan ay na-form because of the equipotential lines na nilagay din natin. No, so, ito, class, ay mga equipotential lines. Ito. Ayan, equipotential lines yan, class, ha. Alright. So, class, dito, no, let's say na dito sa point na to, no, yung head dito, let's say ay h sub 1. Okay, yung piezometric level, no, or yung head dito sa point na to, let's say h sub 1. No, dito naman, class, sa point na to, let's say na yung piezometric head dito ay h sub 2. And then dito rin sa point na to, h sub 3 naman. And then dito sa point na to, h sub 4. No, so, class, again, ang equipotential line, ha, at any point dun sa line na yon, same yung head. So, ibig sabihin, dito sa equipotential line na to, kung h sub 1 yung head dito, ibig sabihin, kahit sa anong point, h sub 1 siya. Ganon din dito, at any point dito, h sub 2 yung piezometric head natin, no? Ganon din dito, ganon din dito. No, so base doon sa ano nga natin, definition ng equipotential lines. All right. So ngayon, class, the rate of seepage through the flow channel per unit length perpendicular to the vertical section through the permeable layer can be calculated as follows. No, so because there is no flow across the flow lines. All right. So, class, dito yung rate of seepage, no, through the flow channel, yung kumbaga yung flow niya, no, sa pagpasok dito sa channel na to, class, kung ano yung papasok, yun lang din yung lalabas. Tama? And let's say, class, na itong mga square elements na to, no, so let's say this is ano, no, mga kumbaga mga different layers. No, so class, di ba napag-aralan natin sa stratified soil na kung ano, class, yung papasok dito sa layer na to, yun lang din yung papasok dito sa layer na to, yun lang din yung papasok dito sa layer na to. So, same, class, na magiging flow rate, no, yung bawat square element na to, class. Okay, so same sila ng flow rate, no. So, in this case, class, let's say yung flow rate dito sa unang element ay delta Q sub 1. Okay, so equal yan dun sa flow rate din dito sa ikalawang element, which is delta Q sub 2. Equal din yan dito sa ikatlo. And also equal sa outflow dun sa lalabas, no, which is delta Q. Alright, so from here, class, pwede natin i-apply yung Darcy's law, no? Di ba alam natin, class, na yung flow rate, okay, yung formula niya, class, ay V times A. Or pwede rin nating palitan yung V ng KI. Tama? So, yung Q equal siya, class, sa KIA. KIA. So, ngayon, class, dito, no, itong, let's say, delta Q, no, i-equate natin. Delta Q equal siya, class, sa, let's say, dito sa delta Q1. So, para dito sa delta Q1, so, yung formula natin ay KIA. So, yung K natin ay K, no, so, isang value lang yan since isotropic ito. So, yung I natin, class, ay hydraulic gradient. So, yung I ay head loss over length of flow. No, so, in this case, class, let's say for this element, no, ito yung first element natin. Alright. So, yung magiging head loss natin dito, class, di ba yung magiging flow natin from this point to this point, from high energy to low energy. So, in this case, class, no, dito sa yung flow natin from this point up to this point, yung magiging head loss niya, class, is just the difference of H sub 1 tsaka H sub 2. Tama? Alright. So, ibig sabihin, class, yung head loss natin ay H sub 1 minus H sub 2. Tapos, class, yung length na kailangan natin dito is yung length of flow, which is ito, L sub 1. Kaya, class, yan yung magiging L sub 1 natin. And take note, class, kung ito ay L sub 1. Alright. So, class, di ba square ito? Ito ay square element. So, ibig sabihin, kung L sub 1 ito, ibig sabihin, yung side din na to, L sub 1 din dapat kasi square eh. Tama? And then, class, yung magiging area, yan yung cross-sectional area na perpendicular dun sa flow. So, ito yung flow. Tama? So, ito yung area na perpendicular dun sa flow natin. So, yan, class, ay L sub 1. And then, yung width na pa ganon. Alright, na perpendicular sa screen natin, no? So, in this case, class, sabi naman dito, no, per unit length. So, ibig sabihin, class, let's assume na 1 unit, no, yung length na paganon. Alright, so yung magiging cross-sectional area class ay L sub 1 times 1. Alright, so take note dito class, ang magiging unit natin dito ay let's say kung meter, kung meter per second yung K, meter yung H1, H2, tas meter itong L sub 1, tas itong 1 meter, meter din. Pero dito pala class sa hydraulic gradient, magiging unitless ito. So, yung magiging unit natin dito, meter, meter, meter per second. So, meter cube per second, ha? Okay, so take note. Kasi class itong 1 na to, mawawala yan mamaya eh. No, so, don't forget na meron tayong 1 dyan, ha? At let's say yung unit niyan ay 1 meter, ganyan. Or kung anong unit man. Alright, so, basta yun yung magiging unit, no? Parang distance cube over time. Alright, so, ganun din class dito sa may ikalawang element. So, K, tapos yung magiging head loss ay H sub 2 minus H sub 3. And then yung magiging length ay L sub 2. And then yung magiging cross-sectional area ay L sub 2 times 1. Alright, ganun din dito sa K. Okay, or dito sa ikatlo. So, K, tapos yung head loss ay H sub 3 minus H sub 4. Ito yun. Over L sub 3. Ito yun. And then times L sub 3 times 1. Alright, so take note class of this equation, ha? Alright. Alright. So, class, itong equation 8.7 na na-derive natin, no, as you can see here, itong L sub 1, tas itong L sub 1 na to makakancel. Tama. And then, ganun din dito, L sub 2, L sub 2 makakancel, L sub 3, L sub 3 makakancel. And also, since lahat yan class ay may K, no, pare-parehong K yan, so pwede nating i-cancel yung K, no? And yung matitira na lang dito class ay H sub 1 minus H sub 2 equal to H sub 2 minus H sub 3 equal to H sub 3 minus H sub 4. No, so makikita natin dito class na if the flow elements are drawn as approximate squares, yung drop in the piezometric level between any two adjacent equipotential lines is the same. Alright, so ito kasi class, no, let's say mula dito sa equipotential line na to, papunta dito sa equipotential line na to. No, so class, yan class ay drop. No, isang drop yan. Alright, and class, yung drop na yan ay tinatawag na potential drop. Okay, mula dito sa equipotential line na to, papunta dito sa equipotential line na to, yun ay isang drop. Mula dito sa equipotential line na to, hanggang dito sa equipotential line na to, yun ay isa ring drop. Mula dito sa equipotential line na to, hanggang dito sa equipotential line na to, isa din siyang drop. Alright, so, class, yung, sabi dito, no, yung drop or yung, kumbaga, difference nung head, no, dun sa bawat drop natin, class, ay the same. Alright, as we can see nga dito sa equation 8.7, yung H sub 1 minus H sub 2 equal din siya sa H sub 2 minus H sub 3 equal din sa H sub 3 minus H sub 4. Ngayon, class, no, balik tayo dito. No, di ba class, dito sa figure natin na ito, alright, so alam natin class na yung magiging total head loss dito class is yung difference ng upstream at saka nitong downstream. Tama, yung difference nila class ay ito, itong height na to. Tama, so class, di ba magfo-flow yung water natin mula dito sa upstream papunta dito sa downstream. So ibig sabihin class, no, sa pagdaan niya class dito, let's say dito sa flow line. Okay, sa pagdaan niya dito class sa flow line, no? So, yung isang drop, no, ibig sabihin class magkakaroon diyan ng di ba, ng head loss. Isang drop magkakaroon ulit ng head loss, isang drop magkakaroon ulit ng head loss. So, ibig sabihin class, yung total head loss natin, which is ito, no, kapag dinivide natin siya sa number of drops, no, ang makukuha natin class is yung individual head loss nung bawat drop. Tama? So, ibig sabihin, class, ito yon yung H. So, yung H, class, yan yung total head loss, which is the difference of upstream at saka downstream. Okay, so kapag dinivide natin yan sa number of drops. So, dito, class, kung bibilangin natin yung number of drops. Okay, so, di ba, ang definition nga natin ng potential drop ay, tawag dito, drop sa pagitan ng dalawang two adjacent equipotential line. So, in this case, di ba class ito equipotential line to? Nasa boundary condition natin yan. So, from this equipotential line, papunta dito sa equipotential line na to, isang drop. Mula dito sa equipotential line na to, papunta dito, isang drop. Mula dito hanggang dito, isang drop. Mula dito hanggang dito, isang drop. Isang drop, isang drop. So, ibig sabihin, class, kung bibilangin natin yung drops ay 1, 2, 3, 4, 5, 6, no, dito, sa flow net na ito. Alright, so ito yung class ha, itong equation 8.8 na to. Kapag dinivide mo yung total head loss, no, dun sa number of drops, yung makukuha mo is yung individual drops, no, nung bawat, bawat potential drop natin. Alright. So, ibig sabihin, class, yung delta Q, ito yun. Okay, so yan, class, ay K, okay, times H over N sub D. Tama? So, dito, class, let's say, ito i-consider natin. Okay? So, ito, class, yung H sub 1 over H sub 2 natin, di ba, equal yan sa H over N sub D. So, pwede natin yan palitan, itong H1 minus H2 ng H over ND or N sub D times K. No? Ayan. So, ito, class, ay equation 8.9. Okay, so again, class, yung H ay head difference between the upstream at saka downstream side, and then yung N sub D ay number of potential drops. Alright. So, dito, class, sa may figure na to, 8.2b, no, yung H natin or yung head loss natin ay H sub 1 minus H sub 2. So, ito yon yung makukuha natin. And then, yung number of drops nga dito, class, ay 6. Alright. So, if the number of flow channels in a flow net is equal to N sub F, the total rate of flow through all the channels per unit length can be given by this equation. So, kumbaga, itong equation na to, class, di ba, isang channel ito. Tama, isang flow channel ito. No? So, kung bibilangin natin, class, lahat ng flow channel, alright, so, imumultiply lang natin yon dito. So, it will become K times H over N sub D times N sub F. Wherein yung N sub F, again, class, yan ay number of flow channel. So, in this case, class, kung bibilangin natin yung number of flow channel, no, base dun sa definition ng flow channel, yan, class, ay strip daw or path, no, sa pagitan ng dalawang flow line. So, class, dito, i-recall mo, boundary condition natin, itong ACD ay flow line yan, di ba? Okay, so, ibig sabihin, ito, isang flow channel ito. Tama? Tapos ito, isang flow channel din ito. Ito din, isang flow channel. And also, ito, class, take note, class, itong FG ay flow channel, flow line din. Tama? So, ibig sabihin, ito ay isang flow channel din. So, kung bibilangin natin yung flow channel, 1, 2, 3, 4. So, in this case, class, 4 yung flow channel. Okay, so, ito, class, yung formula na gagamitin natin, class, sa pag-calculate ng seepage dito, no, using flow net. Alright. Although drawing square elements for a flow net is convenient, it is not always necessary. So, actually, class, instead of using square elements, no, so pwede rin actually tayo gumamit, class, ng rectangular na elements, okay, or rectangular mesh for a flow channel. Ayan, so as you can see here, dito, class, sa may flow channel na to, no, so meron tayo, class, B sub 1, tapos meron tayong L sub 1. So, hindi sila same ng dimension. So, hindi sila square. No, pero, class, ganito, kung rectangular element, no, yung gagamitin natin, class, no, sa pag-construct ng flow net natin, no, ang rule dito is that, let's say, for the whole or entire channel, dapat, class, pare-pareho ng ratio yung length at saka width nung rectangle. Okay? Ayan. So, sa buong ano yun, sa buong flow channel yun. Alright. So, provided that the width to length ratios for all the rectangular elements in the flow net are the same. So, in this case, equation 8.7 for rate of flow through the channel can be modified to, ayan. So, ito, class, yung sa 8.7 kanina. No? So, dito, class, instead na L sub 1 din ito, so ito magiging B sub 1 na ito, no? Ito na yon times 1, no? Yung paganon, yung width or length paganon. Ganon din dito, instead na L sub 2, magiging B sub 2 na to, and then dito, magiging B sub 3 na siya. Alright, so, dito class, yung B sub 1 over L sub 1, no, equal din yan class sa B sub 2 over L sub 2, equal din yan class sa B sub 3 over L sub 3. Kasi nga, dito class, ang rule natin, dapat yung width to length ratio ng mga rectangle ay the same. Kaya, equal yung mga yan, yung ratio nila, no? Ayan, so, plus we are going to let this ratios n, no? So, n yung gagamitin natin. So, the elements are not square. And so, pwede natin class i-modify yung equation 8.9 tsaka 8.10 kanina dun sa previous slide natin. Alright, as this. So, yung delta Q, kanina, equal lang yan sa K H over N sub D. So, dito class i-multiply natin by N. Alright, ito class ay for individual channel. No? Ngayon, kapag sinama na natin yung lahat ng flow channel natin, so yan class ay K, H, no, times NF over N sub D times N. Okay? So, dito class yung N, no, again yan class yung width to length ratio ng rectangular elements natin. Ha? Alright. Alright. So, mag-illustrate tayo dito class ng example. No? So, figure 8.6 shows a flow net for seepage around a single row of sheet piles. Note that flow channels 1 and 2. Alright. So, ito class yung flow channel 1. Ito yung flow channel, unang flow channel. And then, flow channel 2 ito. Alright. Sila daw class ay mga square elements. Yung mga elements dito sa mga flow channels na ito. Alright, hence, the rate of flow through these two channels can be obtained from equation 8.9. And so, class, dun sa equation 8.9 natin, for each channel, di ba, yung flow rate natin ay K times H over N sub D. No? So, kapag inad natin yung flow rate nung channel na to, tsaka nitong channel na to, so, pag-aadin lang natin sila. Tama? So, kumbaga, one channel, tapos, isang channel din. So, dalawang channel yan. So, kumbaga, parang i-multiply lang natin by 2. Tama, yun yung magsaserve as N sub F. So, no, so i-add natin. So, ayan class ay magiging 2 times K times H over N sub D. Ngayon, para pa lang yan class sa unang dalawang channel. Ngayon, meron pa tayong isang channel ito. Alright, so this is our third channel. And nakalagay dito class na yung ratio ng length at saka width niya ay 1 over 38. So, ito class ay hindi square, yung mga elements dito. Alright, so yung mga elements dito class, ang ratio ay 1 over 38. Length over, ano yan ha, over width. Alright, so dito class, no, yung width to length ratio natin bale ay 0.38. So, ito class ay ano ha, mapagbabaliktad kasi yung N natin, di ba, dun sa previous slide natin, yung N natin ay B sub 1 over L sub 1. No? So, yung N natin, class, ay 0.38. Yun yung width to length ratio. Alright, so dito, class, ibig sabihin, yung flow rate natin dito sa flow channel 3, yan, class, ay K times H over N sub D times yung N. Tama? Yan yung width to length ratio or B over L, which is 0.38. No? So, ito class yung magiging flow rate dito sa flow channel 3 natin. Ngayon, kapag pinagsama-sama natin yung tatlo, ito, tsaka ito, so what happens is, ito, plus ito, so ito class ay magiging 2.38 K times H over N sub D. So, kumbaga, yung 2.38 dito class, it will serve as the N sub F or number of flow channel. No? So, ayan, dito kasi class, no, yung flow, ano nga natin, yung flow channel natin. Alright, so, yung, di ba sa bawat, ano nga, flow channel, yung ratio dyan, no, kung puro square yan, no, same yan class lahat ng ratio, lahat sila puro 1. Di ba? So, ganun din dito sa, let's say ito, puro square din itong second flow channel natin. So, yung ratio niya din ay 1. So, dalawa na. Tapos ito class, yung ratio nga dito class ay 0.38. Kaya kapag binilang natin yung flow channel, 1 plus 1 plus 0.38. So, yun nga, magiging 2.38 siya dito. Alright, so ganun natin bilangin yung flow channel, yung number of drops, no? So, that's how we calculate seepage class using flow nets. Alright. Alright, for sample problem number 1, a flow net for flow around a single row of sheet piles in a permeable soil layer is shown in figure 8.6. So ito class yung figure 8.6. Ito rin class yung ginamit natin kanina. So given that k sub x equal to k sub z is equal to k, so ibig sabihin isotropic yung soil natin dito. So equal yung hydraulic gradient class sa 5 times 10 raised to negative 3 centimeter per second. So determine, letter A, how high above the ground surface the water will rise if piezometers are placed at points A and B. So ito class yung point A tsaka point B. And then the total rate of seepage through the permeable layer per unit length. And then letter C, the approximate average hydraulic gradient at point C. So yung point C class ay ito. Ayan na yung point C. Alright. So here class, i-list down natin yung given. Actually, yung given dito sa problem is yung K. No, yan ay 5 times 10 raised to negative 3 cm per second. So, eto na, i-interpret na lang natin to, no, kung ano yung nandito class sa figure natin. Okay, so makikita natin dito class, bilangin natin yung number of drops. Alright, so kung bibilangin natin number of drops, ayan, so ito class ay isang drop, 1, 2, 3, 4, 5, 6, no? Kaya 6 yung number of drops. And then, yung number of flow channel natin, actually, alam na natin class kanina na 2.38, no? So, ito class ay isang flow channel. And then, ito class, since yung ratio nito ay yung B over L niya, or yung width to length ratio niya ay 0.38. So, ito class, flow channel na to ay 0.38, no? So, 1 plus 1 plus 0.38. Yung ends of F natin class ay 2.38. Alright, tapos class yung H sub 1 natin, yan yung head dito, no? From this surface, papunta dun sa water surface natin, dito sa upstream side natin, no? So yan class ay 5.6. Tapos ito naman, no, ito class ay 2.2, no? Yung H sub 2 natin, let's say. Alright, so dito class sa may letter A, no, yung pinapahanap sa atin class is yung elevation nung pagtaas ng tubig above the ground surface. So ito yung ground surface class ha. Kung maglalagay tayo class ng piezometer sa point A at saka sa point B. So mag-start tayo dito sa point A. Ayan. So class dito sa point A, no, yung gusto nating malaman dito class is yung pagtaas ng tubig dun sa piezometer kapag naglagay tayo dito ng piezometer. Alright, so para malaman natin yan, class, kailangan malaman natin kung ano yung head dito sa point A. Alright, so, class, di ba nga, no, mula dito sa point na to, class, ayan, di ba, class, ito ay, itong line na to, no, itong line na to, class, no, dito sa ground surface natin, ito, class, di ba ito ay equipotential line? No, so, ibig sabihin, any point dito sa line na ito, same sila ng head. Tama? Let's say dito sa point na to, no, kung ano yung head dito, pagdating dito sa point na to, yun lang din yung head. Which in this case, no, let's say dito sa point na to, no, kapag naglagay tayo class ng piezometer dito, yung head dito class is ito lang, 5.6 meter. Okay, kapag naglagay tayo ng piezometer dyan class, yung tubig is tataas hanggang 5.6 meters. Alright, dito sa point na to. So, ganun din sa point na to, 5.6, ganun din sa point na to, 5.6. At any point dito sa line na yan. Okay. So, ibig sabihin nga, class, dito sa point na to, no, let's say yung head ay 5.6 meters. Okay. Yung piezometer, tataas siya ng 5.6 meters pag naglagay tayo dito. Ngayon, yung kailangan nating alamin yung head is dito sa point A. Ayan. Class, di ba, mula dito sa point na to, papunta dito sa point na to, isang drop yan. Isang potential drop yan. Ngayon, class, para malaman natin yung head dito, no, since alam natin yung head na 5.6 dito sa point na to, so kailangan lang natin class i-subtract kung ano yung kumbaga potential drop na ito. Kung ano yung head na to, kung ano yung head loss dito sa potential drop na to, isusubtract lang natin sa head natin na 5.6 para malaman natin class yung pagtaas ng tubig pag naglagay tayo dito ng piezometer. Alright, so which in this case class, alam natin yung pagkuha ng ano, 'di ba, nung head loss ng bawat drop, ng bawat potential drop. Tama, so yun class ay total head loss lang, which is H. Okay, tas i-divide natin sa number of drops. Tama, so yun yung kailangan nating malaman muna dito. Okay, so yung head loss class for each potential drop ay Ito yung class, delta H. So, equal yan class dun sa may head loss or total head loss natin over N sub T. In this case, class, yung total head loss natin is yung H sub 1, which is 5.6, minus H sub 2, which is 2.2. So, ito class yung total head loss natin dito. Yan lang yung difference class nung upstream tsaka downstream natin. So, ito class, 5.6 minus 2.2 over 6. Yung 6 ay number of drops ha. Okay, so 0.567 meter class yung head loss natin for each drop. Okay, so pwede na natin class ma-solve yung hinahanap no kapag dito sa point A kapag naglagay tayo ng piezometer dito. So it will just be 5.6 minus 0.567. No, so plus yung kakalabasan dito ay 5.033 meters. No, so ito na class yung hinahanap natin no na elevation nung pagtaas ng tubig above the ground surface. So kung mapapansin mo class, no mas mababa siya sa 5.6 kasi nga nagkaroon na class ng drop, nagkaroon na ng head loss. Mula dito sa point na to papunta dito sa point na to, nagkaroon na ng head loss which is 0.567 meter. Yan class yung para sa point A. Ngayon dito tayo sa point B. Okay? So class, iba yung position or location nitong point B. Tama? Alright. So class, dito baka maisip mo, sir, di ba, ito, equipotential line ito. Ito rin equipotential line. Baka maisip mo, class, na isang equipotential line lang to. Di ba nga ang rule natin, or yung definition natin ng equipotential line, any point dun sa equipotential line na yon, same sila ng head. No? So, baka akalain mo, class, na yung point B ay nasa iisang equipotential line, ha? At baka maisip mo na ito lang din yung sagot. Kapag hinahanap na yung head dito sa point B. No, class, no. So, class, ito ay ibang ibang equipotential line ito. Ibang equipotential line ito, iba din ito. Alright, so magkaiba yan, class. Okay, okay. So, kasi class, di ba, magfo-flow nga yung, let's say, water particle natin mula dito sa point na to, papunta dito sa point na to. So, ibig sabihin, mula dito sa point na to, no, papunta dito, magkakaroon yan class ng head loss. Papunta dito, magkakaroon yan ng head loss. Papunta dito, magkakaroon yan ng head loss hanggang sa makarating siya dito. Tama? So, kapag nakarating na siya dito, class, dapat yung magiging head loss is kung ano yung head dito sa point na to, which is 2.2 dapat. Okay? Alright, so ibig sabihin, class, iba yung makukuha natin na sagot dito sa point B, ha? Ibang equipotential line ito, iba din ito, ito din iba, ito din iba, ito din iba. No? So, kung ano lang ha, sige, bilangin natin class yung equipotential lines natin dito. Okay, so class yung number of equipotential lines natin dito, 1, 2, 3, 4, 5. Okay, ito rin, equipotential line, 6. Ito din, equipotential line, 7. Okay, tas yung flow line, sige, bilangin din natin flow lines dito. Okay, so class, di ba, isang flow line ito. Ito yung, kanina, A, C, D ata yun, ito. Tama, flow line. Yan plus yung surface nitong sheet pile natin. Isang flow line yan. 1, 2, 3. Asan pa yung flow line? Ayan, ito rin class, flow line ito. Tama, 4. 1, 2, 3, 4. No, 4 yung flow lines natin dito, class. Alright. So, dito class, nasa na tayo? Dito na tayo class sa may point B. So, dito class sa may point B, mag-start tayo dito sa upstream. Dito, diba dito sa point na to class, 5.6. So, isusubtract lang natin yung head loss sa bawat drop na dadaanan, which is 1, 2, 3, 4, 5. So, 5 drops, potential drops yung mangyayari class. So, 5 0.567 meters yung isusubtract natin sa 5.6. Kaya magiging 5.6 minus 5 times 0.567 is equal to 2.765 meters. So, ito class yung magiging head or yung magiging elevation nung pagtaas ng tubig doon sa piezometer pag naglagay tayo dito sa point B. Alright, so yun yung mga sagot, hindi lang na-i-box pa, pero yun yung sagot, 5.033 sa point A, sa point B naman ay ito. Alright, doon na tayo class sa letter B, the total rate of seepage, okay, through the permeable layer per unit length. So, class, yung formula natin, okay, for rate of seepage ay Q is equal to 2. Actually, ito ay K or N sub F na to. Number of flow channel na to, yung 2.38. And then K times h over n sub d. So, substitute lang natin, class, yung mga given natin dito. Yung k natin, class, ay ito. Yung h natin, class, ay difference nito, h sub 1 minus h sub 2. And then, yung n sub d natin ay 6. So, class, dito, kailangan maging consistent tayo sa mga units natin. Alright. Ito, class, k, no, in centimeter per second kasi ito. Tapos yung h natin, 'di ba, in meters 'yan. Okay. So, in this case, class, ang gawin natin, itong k na lang natin yung gawin nating meters, no? Since centimeter ito, gawin nating meters. So, for every 100 centimeter, meron tayong 1 meter. So, ito, class, ay madi-divide by 100. So, ito ay magiging 5 times 10 raised to negative 5 meter per second. So, para maging uniform tayo na pare-pareho tayong meter. Alright. So, divided by 6. So, ito unitless naman kasi number yan. Tsaka yung 2.38. Number yan or bilang. No? So, walang unit yan. Alright. So, dito, class, kapag sinolve mo ito, ang lalabas na Q ay 6.743 times 10 raised to negative 5. So, yung magiging unit natin dito, class, Q ito ha. So, ito, class, ay meter cube. Alright. So, dito, class, baka magtaka ka ha, kasi ang nakikita mo lang dito, okay, yung nakikita mo lang dito ay meter, tapos ito din meter. So, meter times meter, so meter squared lang. So, hindi, class. Di ba, class, meron din tayong times 1 unit pa, dun sa kanina, dun sa derivation natin. No? So, let's say yun, class, ay 1 meters din, 1 meter din. Okay, kaya ito, class, ay magiging meter cube per second. Kaya naglagay din tayo, class, dito ng per meter. So, ibig sabihin nito, nag-assume tayo, class, ng, kumbaga, 1 meter length, yung paganon. Okay? Alright, so ito na, class, yung hinahanap natin na dito sa letter B. Kaya sabi din dito, class, sa letter B, per unit length. So, yung length na paganon, class, ay inassume natin na 1 meter. Kaya, naglagay tayo dito ng per meter. Alright, so yun ay sagot for letter B. Ngayon, dito sa letter C, sabi dito, the approximate average hydraulic gradient at C. Asan ba yung C? Ito, class, yung point C. And tinatanong sa atin, class, yung hydraulic gradient. Class, ano nga ang formula natin ng hydraulic gradient? Di ba yun, class, ay head loss over L. So, dito, class, sa may point C, no, kuya approximate natin yung hydraulic gradient dito. So, ito, class, no, nandito siya sa may element na to, tama? Dito sa square element na to. Alright. So, dito, class, sa square element na to, ano ba yung head loss? Okay, kasi yun yung kailangan natin, head loss at saka yung L. So, dito, class, sa may element na to, square element, class, yung head loss natin, di ba nga, ito, isang potential drop, di ba yung head loss na nga natin, na-solve na natin, 0.567 meters. So, wala na tayong problema dito sa delta H. No, ngayon, yung L yung problema natin. So, class, yung L natin, yan, class, yung length, no, nung between two equipotential, ano natin, ito, between two equipotential lines natin. Kasi yan, yung, dyan magpo-flow eh, diba? Dito sa point C, kumbaga yung flow ay mula dito, papunta dito, no, sa pagdaan dun sa point C. Alright. So, dito, class, ito, no, approximately, itong length na to, nung square na to, class, no, by using this scale. Pero ito, approximation lang to. Let's say ito, class, ay 4.1 meters. No, so, yan, class, yung magiging L natin. Alright, so dito, class, yung delta H ay 0.567 meter, and then yung L natin ay 4.1 meter. Alright, so ito, class, yung approximately hydraulic gradient dito sa point C. Okay, actually, at any point dito sa square element na to. Tama? So, in this case, class, yung magiging I natin ay, sige, pakisolve, pakipindot sa calculator, 0.567 over 4.1. So, yan, class, ay 0.138. So, yan na yung hinahanap, class, dito sa letter C. Alright. So, merong note dito, class, sabi, yung average length of flow, which is yung L, no, yan, class, ay has been scaled. No? So, ginamit natin yung scale dito para i-approximate yan, yung length na yan. Alright. For sample problem number 2, seepage takes place around a retaining wall shown in figure 8.7. So, ito yung figure 8.7. The hydraulic conductivity of sand is 1.5 times 10 raised to negative 3 centimeter per second. The retaining wall is 50 meter long. Determine the quantity of seepage across the entire wall per day. So class, ito yung tinutukoy na retaining wall. And so magkakaroon daw class ng seepage dito. No? So of course, yung seepage class, it will take place from the high or dun sa upstream, papunta dun sa downstream. So in this case, yung upstream natin nandito. Andito yung high energy. And then yung low energy or yung downstream nandito. So yung magiging seepage natin class ay sa direksyon na to. Okay? Alright. So, dito class, yung hydraulic conductivity, ano lang ito, isa lang yung ibinigay, no? So, ibig sabihin, isotropic ito. No, tas yung retaining wall daw class ay 50 meter long. So, yung 50 meter long class is ito. No, yung haba ng retaining wall na to pa ganon. Okay, kumbaga side view yung nakikita natin ng retaining wall. Okay, so 50 meters daw siya pa ganon. Okay, so pinapahanap sa atin dito class yung quantity of seepage across the entire wall per day. So, Q yung pinapahanap sa atin dito, class. Alright, so yung mga given natin, class, is yung K. Asan yung K? Ito, 1.5. So, kinonvert na natin ito into meter per second, no? So, centimeter per second kasi yan. So, for every 100 centimeter, 1 meter. Ayan, so divide lang natin by 100 ito. Makuha natin yung 1.5 times 10 raised to negative 5. So, meter per second na yan. And then also, yung H natin, class, no, so yan yung difference ng upstream tsaka downstream. So yan class ay nandito na 5 meters. Alright. So solve natin ito class. Yung formula natin dito ay Q is equal to K times H times N sub F over N sub D. Ngayon class, dun sa N sub F, so bibilangin natin class yung number of flow channel dito. Alright. So bilangin natin. So ito yung isang flow channel. Isa, ikalawa, ikatlo. So, meron tayo class tatlong flow channel. And then, doon naman sa number of drops, no? So, dito class yung dito magsisimula yung, natin, yung flow. Okay, so ito class ay isang drop, isa, dalawa, tatlo, apat, lima, 6, 7, 8, 9, 10. So, 10 class yung drops natin. Alright. And then, yung K natin given, no, yung H, alright. So, ito class, direct substitution lang natin dito sa formula natin. Okay. So, ito class ay Q is equal to yung K ay ito. Okay, 1.5 times 10 raised to negative 5 meter per second. And then, yung H natin ay 5 meters. And then, yung N sub F natin class ay 3. And then, yung N sub D natin class ay 10. So, class, yung lalabas dito ay 2.25 times 10 raised to negative 5 meter cube per second per meter. Ayan. So, class, take note, dito sa formula na to, 1 unit, no? Yung length natin, yung paganon, di ba, inassume natin yan na 1 unit. So, in this case, class, no, meron tayong given class na length nung retaining wall, yung length niya paganon. Alright, which is 50 meters. So, ito class, no, itong nakuha natin na to, multiply natin to dun sa given na length nung retaining wall natin. No, and itong per meter na to, makakancel yan. Tama. Alright, so 2.25 times 10 raised to negative 5 meter cube per second per meter. So, multiply natin by 50 meters. So, yung magkakalabasan dito, class, ay 1.125 times 10 raised to negative 5 meter cube per second. Tama ba ito? Double check natin. Alright, 2.25. And so, negative 3 pala ito, class. 1.125. No, times 10 raised to negative 3 pala ito. No, meter cube. Tama, no? Okay, meter cube per second. Alright. So, ngayon, ito class, i-multiply natin ito. Kasi meter cube per second dito eh. Yung pinapahanap sa atin dito class sa may problem is per day. So, yung second class, i-convert natin yan into day. No? So, i-multiply natin ito, class. No? For every 3,600 second, meron tayong 1 hour. No? So, yung second makakancel. And then, for every 1 day, meron tayong 24 hours. So, makakancel yung hour. So, yung matitira dito, class, ay day. No? So, ito, class, ay isolve natin. No? So, class, ito ay raised to negative 3. Ayan, hindi lang yan na-edit. Times 3, 6, times 24. So, yung lalabas dito, class, ay 97.2 meter cube per day. So, ito na, class, yung sagot dito sa problem na ito. Alright. Alright, for sample problem number 3, two sheet piles were driven 4 meter apart into clay sand as shown in figure 8.8. So, ito, class, yung figure 8.8. So, ito, class, yung two sheet piles natin. No, and they are driven dito sa clay sand. Ito yung clay sand. Alright. And then, class, yung pagitan ng dalawang sheet pile na to ay 4 meters, ha? And as you can see here, dito, class, sa side na to, merong tubig. And then, dito rin sa side na to, merong tubig. No? And then, sabi dito, class, a 2-meter depth of soil between the two sheet piles was removed. So, yung pagitan ng dalawang sheet piles ay ito, di ba? So, sabi dito, class, meron daw dalawa, or merong 2-meter na lalim ng soil na tinanggal dito. So, ibig sabihin, ito, kasi 2 meters to, no? Ito, 2 meters. Alright, so ibig sabihin, originally, meron din, class, soil dito. No? So, tinanggal daw yun, class, yung soil na yon na nandito. So, 2 meters yon. Alright, so, class, sabi dito, to facilitate some proposed construction work, the region between the sheet piles is being dewatered where the water level is lowered to the excavation level by pumping out water continuously. So, class, sabi, no, merong ipapump out na water dito, no, dun sa in-excavate. Kasi, class, dito, ang mangyari, since in-excavate natin ito, no, at yung, kumbaga, level niya ay napunta na dito. So, yung mangyayari, class, yung water natin, class, ay magfo-flow. Again, class, di ba, magfo-flow siya from high energy to low energy. In this case, class, yung high energy natin ay nandito sa side na to. And then, yung low energy nandito. So, ibig sabihin, magfo-flow, class, yung water natin mula dito sa upstream, papunta dito sa downstream. Ganon din dito sa right side. No, mula dito, class, sa may upstream, papunta dito sa downstream. Okay, so magfo-flow yung water natin, no? From that direction. Alright, so, ibig sabihin, class, nga, since may magfo-flow na water from here, papunta dito, no? So, class, mayroong tubig, class, magtutubig dito. No? Kumbaga, magkakaroon ng seepage mula dito, papunta dito. No? So, yung tubig, class, na napupunta dito, class. Alright, so, kailangan daw yun i-pump out. No? So, ipapump out yun continuously. Okay, ngayon, class, assuming the hydraulic conductivity of the clay sand as 2 times 10 raised to negative 4 cm per second, estimate the quantity of water that has to be pumped out per meter length per day. Okay, so tinatanong sa atin, class, yung quantity of water na ipapump out dito. No, so definitely, class, yung rate of seepage mula dito, papunta dito, tsaka actually, yung rate of seepage din mula dito, papunta dito, yun yung quantity, class, no, nung water na ipapump out. Kasi yun yung magfo-flow dito eh. 'Di ba? Yun yung amount of water na mapupunta dito. So yun yung ipapump out. So yun yung hinahanap din natin, class, yung Q. Alright, so para, class, ma-solve natin yung Q, i-ano muna natin mga given, i-list down muna natin. So yung K given, so kinonvert lang natin ito, class, into meter per second since yung given hydraulic conductivity ay in centimeter per second. So gawin nating meter kasi puro meters yung mga dimensions natin dito eh, no? Alright, so it will become 2 times 10 raised to negative 6 meter per second. Ayan. And also, class, yung H natin, ito yung ano, di ba, head loss. Total head loss. So, yun yung difference lang, class, nung upstream at saka downstream. So, in this case, class, ang i-consider lang muna natin is yung left side. Tapos, later on, i-times 2 na lang natin, no, para ma-consider din yung right side. So, considering the left side, okay, so, class, ito, since symmetrical naman sila, no, ito-times 2 na lang natin mamaya. Alright, so dito, class, yung difference ng upstream at downstream, ito yung upstream, ito yung downstream. So, yung difference niyan, class, ay ito 2.5 daw to, tapos ito 2 meters daw. So, yan, class, ay 4.5 meter na yung H natin, yung total head loss. Alright, so, class, bilangin din natin yung number of flow channel. Okay, so as you can see here, ito ay 1, 2, 3. So, 3, class, yung flow channel natin. And then, bilangin natin, class, yung potential drop. So, in this case, class, dito, class, walang, ano dito ha, walang equipotential line dito ha. Baka akala mo may equipotential line. Pero dito, meron. Ito, may equipotential line yan. Alright. Okay. So, dito, pwede nating masabi na walang equipotential line dito kasi hindi naman square ito. Di ba? Hindi naman square yung mabubuo dito. Dito, pwede natin sabihin kasi square, pwedeng square yung mabuo dyan. No? Ayan. Anyway, so, dito class, bilangin natin yung potential drop. So, isa. So, dito magfo-flow. So, dito magsisimula. Isa, dalawa, tatlo, apat, lima, anim, pito, walo, siyam, sampu. So, 10. Ulitin ko. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, we have 10 potential drops. Alright. And then, next, solve na natin class yung pinapahanap na Q. Alright, so yung left side muna yung i-consider lang natin, tas times 2 na lang natin. So yun class IQ is equal to K times H times N sub F over N sub D. So given naman na lahat, alam na natin yung K, yung H, yung N sub F, tsaka N sub D. So yung K natin, kinonvert na natin yan to meter per second. Then yung H natin in meters yan, 4.5 meter. And then N sub F natin 3 over 10. Okay, so yung class makukuha natin na Q dito ay 2.7 times 10 raised to negative 6 meter cube per second, tapos per meter. Since nag-assume tayo dun sa derivation natin, di ba, ng per unit length. No? So, in this case, class, per meter length, no? Per meter length. Alright, so actually, class, per day, ito. Ito, class, ay per second. No? So, class, i-multiply natin, or i-convert natin ito, class, into day, yung seconds. Okay, so multiply natin ito class by 3,600 second per 1 hour para makancel yung second. And then for every 1 day, meron tayong 24 hours para makancel yung hours. So yung matitira dito class ay day. No? So class yung lalabas dito ay 0.233 meter cube per day per meter. So ito na class yung hinahanap dito, no, sa left side. So class, meron pang isa pang kalahati. Ito yon. So class, we're going to multiply this by 2. No, so yung kakalabasan class ay 0.467 meter cube per day per meter. So ito na class yung hinahanap. Alright. Alright, we will now proceed to the flow nets in an isotropic soil. So class, yung flow net construction na dinescribe natin kanina and yung dinerive natin na equation 8.10 at saka 8.13 for seepage calculation, they are based on the assumption na yung soil natin class is isotropic. However, in nature, most soil exhibits some degree of anisotropy. No? To account for soil anisotropy, with respect to hydraulic conductivity, kailangan natin class i-modify yung flow net construction natin. So, class dun sa may equation of continuity natin for two-dimensional flow, na 'di ba originally ito 'yon, no? And since inassume nga natin kanina na isotropic, so yung etong k sub x tsaka k sub z ay equal, so pwede silang makancel. Tama? So yung natitira lang ay ito tsaka ito. No, however, dito class, since hindi nga sila equal, so it will just retain here, no, yung k sub x at saka yung k sub z. Okay, so in this equation class, yung or in this case, itong equation na ito class, it represents two families of curves na hindi orthogonal or hindi nagmi-meet at 90 degrees. Alright, so itong ano na ito class, itong equation na to, pwede natin siyang i-rewrite as this. No, so class, pwede natin i-divide both sides by, let's say, k sub z para makancel yung k sub z dito. No, so yung mangyayari, this will become k over z. And then, nasa numerator to, di ba, yung k sub x. Okay, so kapag inilagay natin din yan sa ilalim, no, magiging k sub z over k sub x. Alright, so dito class, ito, equivalent lang din ito dito, ha. Okay, so what we're going to do class, no, let's say na ipasok natin yung k sub z over k sub x dito sa may partial na to. No, so it will become partial k sub z over k sub x times x squared. So in this case class, no, ito, no, equivalent din siya dito. Itong square root of kz over k sub x times x, tapos quantity squared. No, so equivalent din siya dito kasi kapag inano mo naman to, let's say square root, makakancel lang din yan. And then ito, x squared. Tama? So, yun lang din ito. Alright, so from here class, itong square root of kz over kx times x. Okay, so, pwede natin class i-express ito. okay, as x prime. Okay, so yung x prime equal siya sa square root of k sub z over k sub x times x. Alright, so ibig sabihin, pwede natin itong i-rewrite as this. No? So ito class ay x prime squared here. Okay? And so yun lang naman yung napalitan dito, no? Alright, so ito class yung x bar na to, no? Ayan, so nire-replace niya class yung x. 'Di ba yung x class yun yung horizontal axis natin? So, class dito, since yung soil natin ay anisotropic, yung x na coordinate natin class ay mare-replace ng x prime. Wherein yung x prime class, yan yung magiging new transform coordinate. Okay, so nire-replace niya class yung x-axis. Alright, so ito class yung formula ha nung kumbaga transform coordinate natin. Let's say meron tayong given na x coordinate. No? So para malaman natin yung x prime, no? Or yung transform coordinate niya. No? Ito class yung formula ha. Alright. So in this case class, yung rate of seepage per unit length can be calculated by modifying equation 8.10 to this one. Alright. So class yung, di ba dun sa isotropic, Q is equal to K times H times N sub F over N sub D. So dito class sa may anisotropic, yung K natin or yung equivalent nung K natin ay kailangan nating makuha. Since dito meron tayong dalawang K, yung K sub X at saka K sub Z. So yung magiging equivalent K niya class is pwede nating gamitan ng geometric mean formula. So ito class yung geometric mean formula. So in class ay square root ng K sub X times K sub Z. No, so ito class, yung value nito class ay equivalent na hydraulic conductivity. Alright. Okay. So, in this case class, yung H, head loss pa rin naman yan. Yung N sub F at saka N sub D, yan pa rin yung number of flow channel, saka number of potential drops, respectively. Alright. Alright, so dito class sa may anisotropic, no, note that when flow nets are drawn in transform sections, no, this is in anisotropic soils, the flow lines and the equipotential lines are orthogonal. And so, plus dito, before natin ma-drawing yung flow net natin, kailangan muna natin class i-convert yung through section natin dun sa transform section. Okay, so like for example, dito class, no? Class, ito yung true section natin. So, ito yung merong mga true dimension. No? So, meron dito class nakalagay na scale na with this length, no? Yan ay 20 feet. Alright. So, ito class yung true section, ha? So, class, before natin ma-construct yung flow net natin, kailangan muna nating i-convert yung true section natin into transform section. Okay? So, sabi dito class, however, when they are redrawn in a true section, these lines are not at right angles to each other. So, kailangan muna natin class i-convert yung true section dun sa transform section para masunod pa rin natin class yung rule natin sa pagdodrawing ng flow net na dapat yung intersection ay mga 90 degrees, no? Ayan. Kasi class kapag dito tayo kumbaga naggawa ng flow net, no? So, dito class hindi exactly 90 degrees. No, yung mga magiging natin, yung magiging yung mga intersections natin. All right. So, sabi dito, this fact is shown in figure 8.10. In this figure, it is assumed that K sub X equal to 6 times K sub Z. Figure 8.10a, ito yon, shows a flow element in a transform section. The flow element has been redrawn in a true section in figure 8.10b. So class, para ma-drawing natin yung transform section, let's say ito yung true section. Alright. So let's say class, for this scale na 20 feet, no? Ayan. So dito class, 'di ba, let's just say na itong length lang na to. No, let's say 20 feet din siya. No, yung length na 'yan. Let's just say na yan, pareho sila ng length ito. So ibig sabihin 20 feet ito. Okay? So class, para ma-drawing natin yung 20 feet na yan sa may transform section, pwede natin gamitin ito. Itong formula na to. So let's say yung x natin ay 20 feet. No? Ito, let's say ito class ay 20 feet. So kung 20 feet ito, Tapos yung K sub Z natin ay, ito may relationship tayo, no? Let's say K sub Z, tas yung K sub X natin ay 6, K sub Z, so yung K sub Z ay makakancel. So ito ay square root ng 1 over 6. So square root of 1, solve natin, square root of 1 over 6 times yung X, let's say 20. Okay, so plus yung kakalabasan dito ay 8.165. Okay, so ibig sabihin class, kapag dinrawing natin itong 20 feet na to, no, dun sa transform section, which is, let's say, ito. No, ito class ay magiging 8.165 lang. Diba? So, as you can see here, diba, lumiit. No, from true section, papunta dun sa transform section, lumiit siya. Okay, so, ito class yung transform section. So, that's how we, that's how we convert yung true section dun sa transform section. And take note dito class, sa transform section, no, yung nagbabago lang dyan is yung horizontal na scale. Okay, yung vertical class will just remain the same. Okay, so which in this case class kasi mukhang lang, hindi maayos yung pagkaka illustrate dito, no? So sa vertical axis class, no, kumbaga walang mababago diyan. Kung ano yung vertical scale dito, yun lang din yung vertical scale dito. Alright, so nagbago lang siya sa horizontal. Alright. Alright, let's now solve sample problem for flow net in an isotropic soil. Alright, a dam section is shown in figure 8.11a. So, ito class yung dam section. So, ito yung dam class. Okay, and then may water dito. No, may permeable soil tayo. Tapos ito yung downstream, upstream, downstream. Alright. So, the hydraulic conductivity of the permeable layer in the vertical and horizontal directions are 2 times 10 raised to negative 2 mm per second and 4 times 2 raised to negative 2 mm per second, respectively. So, obviously, class, anisotropic yung soil natin dito since nagbigay ng hydraulic conductivity in the horizontal and vertical directions. Alright, so, calculate the seepage loss of the dam in feet cube per day per feet. So, seepage loss or rate of seepage, so same lang yan. So, yung magiging flow ng water natin dito, class, is from upstream. So, definitely mula dito, papunta dito, class, sa downstream natin. Alright, so, alamin natin, class, yung rate ng seepage, which is yung Q. So, that will be in feet cube per day per feet. Alright, so, dito, class, sa solution natin, okay, so from the given data, plus dito mapapansin mo, merong flow channel dito na sabi 0.5. No, ito 1, 1, 1. So, ibig sabihin mga square yung nandito sa flow channel 1, flow channel 2. Okay, so dito sa third flow channel, okay, 0.5 class yung ratio no, nung base, or nung width niya to length. Okay, so by the way, dito pala class, anisotropic ito. So, itong section na nakikita natin na ito class, itong flow net na ito, this is already in transform section, ha? Okay. Alright, so, from the given data class, yung K sub Z ay 2 times 10 raised to negative 2 mm per second. So, class, dito, yung tinatanong kasi feet cube per day per feet. So, i-convert natin yung millimeter per second to feet per day. So, to convert that, so 2 times 10 raised to negative 2. No, so for every one, kung ako, i-convert ko to for every, let's say, 1,000 millimeter, 1 meter. Tapos, 1 meter, 3.28. Tama ba? 1 meter, 3.28 feet, no? Okay, tapos para naman dun sa second, 3/6 second, 1 hour. And then, 24 hours, 1 day. So, ito class ay 5.66784. So, let's just say na 5.67 feet per day. And then, para naman class dito sa may K sub X, yung 4 times 10 raised to negative 2 mm per second, convert din natin to feet per day. So, yan class ay 11.34 feet per day. Alright. And also class yung H natin, which is yung total head loss natin, yun lang yung difference ng upstream tsaka downstream, that is 20 feet. Alright. So, class, yung rate of seepage natin, since anisotropic ito yung formula natin, class. Q is equal to square root of K sub X times K sub Z times H times N sub F over N sub D. So, class, yung N sub F natin, number of flow channel, isa, dalawa. So, class, dito, 0.5 lang ito. So, 2.5 yung flow channel natin. Okay, tapos yung number of drops natin, okay, yung number of drops natin, class, mula dito sa upstream, isa, 2, 3, 4, 5, 6, 7, 8. So, yan, class, ay 8. So, i-ano lang natin, class, i-substitute lang natin dito sa formula natin. So, this will become square root of 5.67, yung K sub Z, 11.34, yung H, 20 feet, N sub F, 2.5, yung N sub D, 8. No? So, class, mga feet na to, no? Feet ito, feet ito, feet ito. So, yung kakalabasan na nito, class, ay feet cube, no? Per day, no? Kasi per day na din ito. Alright. So, dito, class, nag-assume tayo, no, sa derivation natin, ha, na 1 unit length. Okay? So, let's say na per feet, no? 1 unit foot or 1 foot yung inassume natin na length. Okay, so dito, class, yung magiging sagot ay 50.12 feet cube per day per feet. So ito na, class, yung sagot for this problem. That ends our discussion for this topic. I hope that you learned, class. See you again sa next video natin. Bye-bye. Aral mabuti. Keep safe.